Okay, now let's take a real life problem about limits. Let's imagine we have a lab technician who controls the temperature T inside a lab. And from the initial temperature of 0 degrees Celsius, he allows the container to increase by 2 degrees Celsius per minute for the next 60 minutes. Now after the 60th minute of the test, he let the container to cool at rate of 3 degrees Celsius per minute. Now, if you know that the temperature function T is defined as T of T, the temperature as a function of time, is 2T as T less or equal to 60, and it is K minus 3T as T larger than 60. Now the question in this case would be, find the K such that the temperature T is continuous at T equals 60. How would you solve that kind of problem? Just to let you know, we have here a function as a temperature in terms of time, T of T. Those functions in real life, you can come up with them by building your data tables. So when you have a group of data tables at a long period of time, let's say for 5 days, you are building your data as heating up the container and lowering the heat for that container, then you can build a kind of behavior in terms of a formula. How does the temperature over time is behaving at the moment where the T equals 60, either before that or after that? So we have that function, we came up with it. So I'm saying here that this is doable in real life. So let's try to solve together branch A of the question. Find the factor A, the factor K in this case, such that the T is continuous at the time equals 60. Now what we can do here, continuous is related to limits. You need mainly to test if the limit here is continuous. As you remember, as the rules of continuity for the limit of that variable from the left should equal to the limit from the right. So we can use that piece of information to find the variable K in this case. Let's move forward. So we say T is continuous at time equals 60. So the limit should exist there as well. So in this case, we can say the limit of the function T of T as x approaches to 60 from the left, that's the function we're talking about, as T approaches to 60 from the left, should equal the limit of the function T of small t as x approaches to 60 from the right. That function we're talking about is this exact function here. As T larger than 60, that means T approaching 60 from the right. Now we equalize these two and we find the solution. So the limit as T of T as x approaches 60 from the left, that means it is the limit of 2t that we see it over here. So the limit of 2t as x approaches 60, plug in the 60 instead of the t, then you have 2 multiplied by 60, that equals 120. Okay, that's the right hand side of the limit. How about the left hand side? As x approaches to 60 from the right, then what you're gonna do, now we get this as 120 equals whatever we'll find here. So 120 equals the limit of k minus 3t as t approaches to 60 from the right. In this case, we plug in number 60 instead of t. So we have 120 equal k minus 3 multiplied by 60, that means minus 180. So we have, if we want to be clear and simple, 120 equal k minus 180. Moving 180 to that side, in this case we have k equal 300. So in this case you found the value of the variable k of 300, and that could be an important factor in your equations or in your research or in your job for whatever you're doing in the lab. So that's one real life problem. Let's try to find another one, same concept but a different category. Let's say you have a candy factory that sells candy by pound. Now the factory charging $1.5 per pound for quantities that up to and including 20 pounds. As long as you're buying 20 pounds or less, he will charge you $1.5 per pound. And if you are buying more than 20 pounds of candy, then the factory will charge you a discounted $1.25 per pound for the entire quantity, plus a quantity surcharge or partial charge of K. So as long as you buy candy less than $20, that's what you pay, 1.5x of a dollar. And if you are buying more than 20 candies, more than $20 of candies, then you will be charged 1.25x plus a partial charge that we don't know, in this case of K. Now the question is saying find K so that the price function P is continuous at x equal 20. Continuous at x equal 20 means, as we learned in the previous example, you want to equalize the limit as x approaches to 20 from the left to as x equal the 20 from the right. So what you do here, same what we did previously, limit as x approaches to 20 from the left. Which function we use? We're talking about this function. It's 1.5x. Since we are looking for continuity, that should equal the limit as x approaches to 20 from the right. Approaches 20 from the right, we're talking about this function. That's 1.25x plus k. Now plugging in 20 instead of each x here and here, that gives you 1.5 multiplied by 20 equals 30, equals 20 multiplied by 1.25, that give you 25 plus k. We are interested in finding k. In this case, k equals 30 minus 25, and that give you 5. So the factor you're looking for in this case is 5. As we said, this factor could be an important thing for the factory or for the lab or whatever you're doing in real life or in your job. You could come up with unknown factors that you need to find by testing continuity.